It's always good to check in with Randall Carlson. We missed Randall at the Cosmic Summit recently. He was the keynote there. From all indications, he rocked the boat as he always does, and people were just astounded at his material. Today's theme with Randall is the great upheaval, and we'll get to exactly what that means shortly. But Randall is a what you can consider a rogue geologist who's traveling the country constantly. And by the way, if you ever want to get a sense of what has happened to our planet, join one of Randall's tours. They're excellent. And he goes all over the United States pointing out geological disasters front and center. So, hey, Randall, good to see you, man. How you been?
I've been great. Good to see you, Cliff.
Fantastic. Hey, how was Cosmic Summit? What was your impression?
My impression is it's just overwhelming. Don't have it really well. I gave a 90-minute presentation, and then I think that was on Saturday, and then Monday I did a 3-hour workshop for anybody who wanted to take it on.
Oh, you did a special presentation on Monday, yeah.
Right. Yeah, I did a class. It was like a classroom on sacred geometry.
Amazing.
So
yeah.
I took people through some of the preliminary drawing exercises.
Yeah, it's funny because George Howard does a good job. He makes sure that everything is streamed, and so we have a lot of people that listen to Earth Ancients from around the world that actually just dial in and capture the streaming. So that's really a good idea.
Yeah, it is. And the people that come together, there's a broad spectrum of people, from hardcore, solid academic scientists, all the way to more, I guess, what you consider fringe, although what used to be pretty much, defined as fringe isn't so fringe anymore. Like Graham Hancock says, everything keeps getting older. And, there's constantly new discoveries that are hard to keep up with, that are really changing our own understanding of the past.
Yeah.
And there's a whole lot more to it than was assumed even a generation or two ago. The human past on planet Earth, and I know you of all people are well aware of this, is much deeper and much more complex than the textbook versions of prehistory.
Yet archaeologists have a really hard stop when it comes to pre-civilization, prehistory. And so you're looking at cultures that may have been around prior to what we're going to talk about today, the Younger Dryas hypothesis. Before we move on, did you get a chance to see the Bell collection of stone artifacts that he brought with him?
The vases, yes. I'd actually seen those when I visited him in Florida at his studio.
You've actually been okay.
Yeah, so he had them in a secured room and let me go in there, and along with my buddy Mike Robertson, who he's the who does the how tube. He was with me, and so Matt let us into the room there, and we were able to handle the vases. And
you actually picked them up. Did you put on some gloves just before you could touch them, or what?
No, I didn't really. I asked him, can I take this vase when we go in to do the interview? Maybe I could have some coffee in here and see if No, I didn't ask him that. So yeah, it's impressive. I mean, they're very highly polished, very, very accurate, precision made. So I don't know enough about pottery and that side of the thing to have much of an opinion, other than the fact it seems to me that, people like Ben Van Kerkwyk and who's the other guy who's been doing a lot of work on there,
Young.
Mark Young?
Yeah, Mark Young.
Is it Mark Young?
Because he has a couple of pieces that he got years ago, and he's presented them personally. So, yeah. But I mean, do you think they were cut on a lathe? Does it look like they were definitely?
It sure does look like it to me.
Yeah, like a machine cut of some kind.
Yeah, they do look like they're precision machine made. I have a hard time understanding how those vases could be made by hand. It's just, But again, I'm not an expert in that. So, if I had been looking at lots of pottery, lots of vases and things like that over the years and had a comparison in my mind, I might be able to say, well, yeah, this one's obviously made by hand and this one is very much more precise.
Yeah.
but I don't have that level of expertise.
Yeah,
But
no, I was just curious because that was kind of a highlight of the conference, and George Howard, the producer, had mentioned it.
mhm.
And I was like, I couldn't get myself out there this year because of other commitments, but I really wanted to see those. Hey, let's talk about the Great Upheaval. This is such a compelling topic. One thing that I didn't realize is that our planet Earth goes through this, I guess it's called Taurid meteor stream, twice yearly. And
Mhm.
for the most part, the meteors and other solid objects are so small that they burn up in Earth's atmosphere. But it's the feeling, your feeling, and a few other people's feelings is that during this impact, this is where this terminating meteor came from, right?
Well, okay, so let's a couple of things here. Let's so sketch out the broad picture for people listening. The Younger Dryas boundary, I mean, which has been known about for decades, but never had a really satisfactory explanation. The more they begin to learn about the Younger Dryas boundary, the weirder it got. And
Right.
it finally, somebody says, well, I think we need to broaden our perspective. And so in 2007, a paper came out. It was lead author was Richard Firestone,
Right.
James Kennett, Alan West, and I think there was 17 co-authors, including George Howard. I think his name was on that paper as well, where they began to look at this well-defined layer. We can, in a minute here, we can pull up so people can see what actually defines that layer. It's called the black mat.
Black
And
mat.
you've heard of that. Yeah. Now there are black mats that are basically they are created in environments where there's moisture, where algae blooms. And so there are different black mat layers with different dating, but there is a very prominent one at the Younger Dryas boundary. And so they took a closer look at that. And what they found there was proxies for impact, for an impact of some kind of a cosmic object, an asteroid or a comet or something in between. Like we now know that the whole definition of comet and asteroid has gotten very plastic because used to be they were very distinct objects in space.
Right.
But now what's happened, there's a lot of hybrids and there's almost a continuum of objects. There are comet-like asteroids and there are asteroid-like comets. So whatever it was, and the critics of the hypothesis, one of the things that they kept emphasizing was that the proxies, you know what I mean by a proxy? In other words, we're not seeing the impact itself or the actual object. So we have to look at the secondary consequences. For example, if you have diamonds, nanodiamonds that are only created under extremely high pressure, right? That's a proxy. So you go, okay, there had to be something here. We don't see the actual object, but we see the effects of that object. So that's a proxy. A proxy might be little marble-like spherules that form when you have a hypervelocity impact. One of the things that it does is it rapidly melts not only itself, but the target material that it crashes into, and that will create a vapor. And when that vapor cools and crystallizes out, it'll rain back to Earth, and you'll get these small little microspherules.
Right.
Sometimes they're very shiny. That's a proxy. And you have metals, platinum group metals that are rare in the surface of the Earth, but abundant in asteroids and meteors like iridium and platinum, osmium, ruthenium. And so if you see, and this is how they discovered back in 79, 80, when the scientists, Walter Alvarez and his father and their team discovered that there had been an impact at the KT boundary, as it's called. That's the one 66 million years ago where the dinosaurs went extinct. For years and years, the question had been, what caused the extinction of the dinosaurs? Well, so Walter Alvarez and his team, they were looking at this boundary layer, very kind of in a way similar to the Younger Dryas boundary layer, except separated by 66 million years, right?
Right.
But they're looking at this boundary layer, and they wanted to know, over this little thick layer, they want to know, okay, how long did it take for this layer here to be deposited? Was it a couple of days, or was it a couple of centuries, or what was it? So they knew that there's a steady rain of cosmic material, a gentle, steady rain of microscopic cosmic material to the Earth from space, right? Iridium is one of those things that comes down in this cosmic dusting that's taking place constantly, even as we speak. But so what they were going to do is they were going to look at the iridium and try to figure out, because they pretty much assumed the rate at which the iridium dust is accreting to the Earth. But then they looked there and they realized that, wait a second, this is like more than 100 times more dense than the background amount. So right there at that KT boundary, you have this big spike of iridium. Above it, it goes back to the background, which is less than 100th, and below it. So you've got this much iridium below it. You've got this much iridium above it, and then in that one little layer, you've got a huge amount of iridium. So they contacted their colleagues around the world and said, go back and take a look at that KT boundary and see if there's an iridium spike. So there were scientists in Denmark and scientists in New Zealand that were early on. They go and they found the KT boundary in Denmark, and they looked at it, and sure enough, there was a huge iridium spike. In New Zealand, they looked, huge iridium spike. Well, over the next year or two, sites all over the world from that 66 million year dinosaur killing era all had this cosmic metal. So then you sort of reverse engineer and you go, okay, it looks like the entire planet got dusted with iridium. Now we know the percentage, the content of iridium that's, say, in an asteroid, right? We know how much is in a meteorite. Mm-hmm. So in order to get enough iridium to dust the whole world, how big of an asteroid do you need to deliver that volume of iridium?
Yeah.
Well, the calculations were about a 6 mile in diameter asteroid.
Oh my God.
Well, I mean, if you've got a 6 mile in diameter asteroid coming in at, say 15 miles per second, think about 15 miles per second. That thing is moving at, 10 to 20 times the speed of a high-powered rifle bullet.
Yeah.
And it's the size of Mount Everest, right? Boom! Okay, that was it. That's set into motion this whole set of feedbacks that it looks like that ultimately took out the dinosaurs. And it may have not been overnight, but it was probably in a very, very short period of time.
And you're telling me that's a planetary wide event. That's what they call a true terminating event, right?
That's a terminating event, yes. Now, the event of Younger Dryas boundary, which is now dated to just a little bit younger than 12,900 years, has similarities and parallels with the dinosaur killing event, but on a smaller scale. Because if a 6 mile asteroid, Cliff, had struck the Earth 12,900 years ago, we wouldn't be having this conversation today. Yeah. In fact, we wouldn't even be here, because human beings, unless they had figured out how to get into space, wouldn't have survived an event of that severity. It was worldwide. There was worldwide firestorms. There were volcanism on a huge scale that was triggered. There was seismic responses, like earthquakes 10 to 100 times more powerful than anything we've experienced in modern times.
Right.
The list goes. Acid rain with a pH of like 1. So, it's like battery acid, a rainstorm of battery acid. Then there was the cosmic winter that, there was, so for decades then the whole planet froze over. I mean, yeah, it was really bad time to be alive. Now, that's 66 million years ago. The Younger Dryas boundary is, like I said, a little bit less than 12,900 years ago. And it's not of the same scale. And yet, relative to what we've experienced in modern civilization and since the rise of modern science, it was extreme. It was an extreme event in its own right. And the more we learn about it, the more widespread it gets. Like at first, it was maybe just regional to North America.
Yeah.
Well, then evidence is being found in Chile, in Argentina, in Patagonia, even looks like in Antarctica. Now it's being found recently. Younger Dryas evidence was found in Siberia. So it looks like it's worldwide.
But it's not
But
considered a terminating event because there obviously was some humanoids that were left. It killed most of the North American, according to the writing, the North American megafauna, the big land animals. But obviously, other parts of Europe and Asia and perhaps the South American area weren't affected as much, were they?
Well, okay, that's a very good question, Cliff. So we can consider that the loss of species is going to be directly a function of the loss of habitat. If you destroy the habitat that a particular species is adapted to and survives in and on that habitat, there's a very good chance that they will go extinct if they don't adapt. And what we see is that both North and South America lost about 75%, about 3/4 of their megafaunal species by the Younger Dryas. It looks like some of the extinctions might have started a little earlier. There may have been a few survivals past the Younger Dryas, but they died out shortly thereafter. But it looks like the Younger Dryas is pretty much the boundary where you see the final termination of the megafauna. Let's define megafauna. Anything more than about 100 pounds in body weight. Okay. So that would qualify you and I, Cliff, as being megafauna. In case you were wondering. So 3/4, roughly 3/4. Now go to Eurasia, about 35%. Go to Africa, about 10. It depends on who's counting, but 10, maybe 15%. So what it looks like is the Western Hemisphere was the more severely impacted, say, than Europe and Asia and Africa for sure. The Northern Hemisphere probably more severely impacted than the Southern Hemisphere. I think that North America was probably ground zero for a series of impact events. But to me, what you can extrapolate from that is that, again, if the species loss is a yardstick for habitat loss, then the greatest habitat loss would have been in North and South America. And I used to think that North America had the most species lost, but South America is right there. They're very close in some, of course, and even with some estimates, South America might have lost a few more species than North America. And I haven't studied the geology and the planetary transitions in the region of South America like I have North America. But when we look at Africa, look at the Serengeti Plain and think about the megafauna. That's the greatest concentration of megafauna on Earth today, the Serengeti Plain. You've got the elephants and giraffes and hippos and rhinos and, all these animals, buffalo, you've got, list goes on, right? You've got lions, you've got cheetahs, you've got all of the, and those basically are left over from the Pleistocene, the epoch that was ended with the Younger Dryas. Right. The Younger Dryas is the sort of the boundary, the marker for this transition between 2.5 million years of the Pleistocene into the 11,600 years of the Holocene. And you think about the Holocene, that's the geological term for it.
Right.
The Holocene is basically where we see the rise of civilization. And think about this, Cliff. If you go back 8 to 10,000 years, and this is when you see what they call it the agricultural revolution, one of these great transitions from a hunter-gatherer migratory lifestyle into farming, right? Okay, so this occurs in that millennia or two right after the Younger Dryas. And we see transition to farming. We see the domestication of animals on a wide scale. Again, within that same milieu, we see the dispersion of languages. If you study languages in the language tree, you see that major dispersion of languages takes place in that same window of a couple of millennia. When did we see the first urban complexes arise? In a few isolated places between 7,000 and 8,000 years ago.
Right.
We didn't really see the major flowering of civilization, for example, in Egypt or Sumeria along the Tigris-Euphrates River Valley or the Indus River Valley in that part of the world, or in, there was a rise of civilization along the Amazon
Right.
at that time. And Graham Hancock has documented that quite well. We see the very first monumental earthwork architecture in America during that same few centuries that is putting us between 4,500 years ago and 5,000 years ago. What's becoming apparent now, Cliff, the evidence is pointing to the fact that just like there were many species that went extinct, you do not think about this. You don't go in and exterminate 3/4 of all species, and then the quarter that's remaining is completely unscathed. And in fact, think about the near extinction of the American bison. Okay, so it roamed, there was millions of them, in the early 1800s. Now you get to the turn of the century, and there's only a few hundred. Now you can go in, of course, into the supermarkets and buy bison burger, right?
Yeah.
But here's the thing: if we're looking back from 10,000 years into the future, you might never know that the bison came within an inch of becoming extinct, right? You could easily miss that. You'd say, there was millions of them there, and hey, look here, 150 years later, we see evidence that they're eating bison burgers, right?
Right.
But think how easy it would be to miss the fact that the American bison almost went completely extinct, but then rapidly recovered. Mm-hmm. Once the conditions change, and whatever forces were driving that mortality, that changes. And so now the species can quickly recover. So my point is, if you extrapolate from that, there was probably a near extinction of all species, like in North America. Mm-hmm. Let's take moose or grizzly bear. There were grizzly bears during the Ice Age, but they didn't go extinct. There were horses in North America, and they did go extinct in North America, but not in Eurasia, right? But here's what I'm getting at. Bring it home. Do you think that events that were that severe, that could wipe out 3/4, and you've got to talk about, if you're talking about mammoths, if you're talking about saber-toothed cats, the giant ground sloths, dire wolves, the giant camels that roam the southern United States, the giant beavers, everything's big, right? The giant armadillos. If you look at all of these creatures, right, they're all completely gone. There couldn't be even a single mating pair left. Every single individual mammoth had to be killed, had to be destroyed. Now, here's the thing I'm getting at. The evidence is now showing pretty conclusively that there was a culture called the Clovis culture, which I know you've heard of the Clovis culture.
Sure.
Right? They occupied North America roughly 300 to 400 years prior to the Younger Dryas. Where they came from is an open question. What happened to them? Because there was over 50 Clovis sites around unglaciated North America that became completely unoccupied post Younger Dryas. So there's two questions. Where'd they come from? What happened to them? Well, I think what happened to them was the Clovis culture became extinct. Most of them were killed off by the same catastrophes that wiped out the woolly mammoths and the rest of the megafauna. Now, and this is showing up all over the world. We're seeing evidence that there was a major population crash coming out of the Younger Dryas, right? And the next 3, 4, 5,000 years, I think what the evidence is now showing is that just like the American bison, once recovered, human species began to recover. But it took 3,000 to 4,000 years. And the reason we see this flowering of civilization all in that milieu between 4,500 and 5,000 years ago is because it essentially took that one. You're not going to build monumental architecture if you don't have a labor force. You got to there's got to be more people. And to undertake something like that, you have to have enough people that there's a whole segment of society that's providing the food, the clothes, the shelter for the labor that is building the temples and the monumental earthworks in North America and South America and so on. So you have to have this recovery. And I think that's why we don't see a lot of stuff up until about 4,500 to 5,000 years ago. And then almost as if somebody blew a whistle. You see this flurry of activity. You see it in Samaria. You see it in Egypt. You see it in the along the Indus Valley. You know, the whole civilization that arose there. You see it in North America. You see it in South America, and you see it in British Isles and Northern Europe. Because think about Stonehenge and so on. Those early megalithic structures in the British Isles date to that same period.
But are those all reboot sites, Randall? Are we talking about reboot sites?
Now, there's a great question. Yeah, I think in a lot of cases we are, because there's evidence that many of those sites were occupied earlier and were considered to be, if you want, sacred, whatever that we define that term to mean. I would say that it probably implies that there's a special quality or energy to these sites related to the geological composition and structure of the site and its relation to the heavens above. I think we're looking there possibly at an ancient science of uniting heaven and earth, because doesn't it seem, and I know you've now seen enough of this to see the similarity, the underlying similarity of so many of these ancient structures. Even though they don't look, you could look at Egyptian pyramids or an Egyptian temple. It looks very distinct from, what they were building in Samaria with the ziggurats and the stepped. It looks very distinct from what they were doing in North America with these. I don't know if you've ever visited any of the.
It's funny. I haven't been to any of the mound builders, but I gotta go. I gotta go on a Randall Carlson tour.
Cliff, I'm not gonna give you any rest. You got to get out and see what.
Got to get out and see him, especially up and down the Mississippi.
Yeah, Cahokia will blow your mind.
Yeah,
I mean that what's called the Monk's Mound is just enormous.
Yeah,
and you're going to be going, okay, how many people did it take to build this thing? And then, of course, for every person that's engaged in that, there's got to be 10 people that's part of the support infrastructure. And that's an important point. But what I'm getting at is it looks like we got a model. And of course, this would be subject to refinement and improvement and all of that. But it looks like there was a mortality event, that a bottleneck in human population around the world. It took 3,000, 4,000, 5,000 years for the human population to recover to the extent that we can now look and see the fruits of their handiwork.
Okay, but you're saying 9,500 years approximately is when this impact came, wipes out megafauna, wipes out whatever. I think you said last time it was around roughly 85% of humanity estimated was destroyed. This is the Atlantis question. Atlantis was destroyed. Other sophisticated early Egyptian cultures, perhaps there were pre-Inca people who were around building stuff.
Yeah.
And this is Graham's story. Graham's talking about these earlier people. What is the evidence? Now, I have been to Egypt every year. I think the pyramids are pre-Cataclysm. I think the culture that built them were brilliant engineers, and that is a calling card for them. But we don't have traditional science does not believe there was a pre-culture, a pre-devastation culture, because according to them, there's no pot shards. But I think we're getting there now. I think our technology is getting there. You look under the water, and there's evidence of ruins.
Yeah.
Well, let's talk about one or two of these ruins that were part of this impact. What about, we talked about Tiwanaku in Bolivia beforehand. That place, Randall, is cut by a group of geniuses. We don't know what the technology was. It looks like a welding torch of some kind of laser. And these are megaliths of a precision that we just can't conceive of.
Oh, I know. It's pretty mind-boggling. It sure is. And one of the points I try to make, we were talking about the great upheaval, but one of the points I try to make is that many archaeologists, even geologists, are not trained in catastrophic geology.
That's a good point. Yeah.
Yeah, they're not trained in catastrophism. They don't know, they haven't necessarily studied the effects of hypervelocity impacts, solar outbursts and coronal mass ejections and what effects they may have, the effects of what an ice age will do, rising, think about sea levels rising and falling more than 400 feet, the great floods where you have these gigantic, unbelievably huge floods sweeping over the land. They don't really, that's not part of their worldview. And so what they don't understand is that, when they came up and were trained, geologists were used to be trained. The fundamental concepts of geology and Earth history were called uniformitarian.
Right.
Right. So which is a very powerful tool to use to understand the past. The problem is that we can look and we can go, okay, the present is the key to the past. So if we're trying to decipher events that happened in the past, we refer to things that we can see going on today, and we essentially extrapolate backwards. Now, within that framework, you might have a local catastrophe like a volcano going off or an earthquake, but you don't have anything that encompasses an entire continent or much less the world as a whole, right?
Right.
Okay, so in that model, you might go, okay, well, if everything is changing so slowly, one grain of sand, one drop of water at a time, we don't really even notice the change over a single lifespan. It requires multiple lifespans, right? Well, okay, so now you've got this false picture because it's half correct, but it's missing a whole half of the equation. Is that from time to time, that nice placid pace of slow incremental change suddenly gets interrupted in a major way, and boom, the proverbial hits the fan big time. If you don't take account of that, you're not going to be able to have a realistic model of the human past. And when you see the direct effects, let's say, of a water flow over the land of 500 million cubic feet per second, you realize that it doesn't matter what was there. Whatever was there is completely eliminated from existence. You could have had a city there, and 500 million cubic feet per second is going to wash the entirety of that city away.
You're talking about flooding, right?
Flooding, yes, flooding.
Okay.
And flooding, gigantic floods were part of this whole great upheaval. It encompassed both firestorms on a large scale, and it encompassed we now know volcanic eruptions on a huge scale. It involved major seismic shaking and earthquakes. And then one of the effects was these gigantic floods that are being documented from having occurred all over the world. There were tsunamis, apparently, that were huge. There's a tsunami, Dallas Abbott is a scientist who's been studying the effects of tsunamis on the continental coastlines of the world, and they're everywhere. There's the one in Madagascar off the east coast of Africa.
Oh, the most recent one, yeah.
Yeah, it appears to be associated with a submarine crater. It's about 2 miles under the water. That would have generated a giant tsunami. And when it made landfall against Madagascar, it was at least 650 feet high. Now, we've seen the devastation that can be caused, like the 2004 Indonesian tsunami that killed 250,000 people. You watch those videos, they're mind-blowing. Or the videos of the tsunami that hit Japan back when the nuclear reactor got affected. You remember that?
Yeah.
Right. And so you look at those videos and you go, okay, here's a tsunami wave that's 30 to 50 feet high when it makes landfall. What would a 650 foot tsunami do to the coastlines? Right. So if you had a city, if you had a village, a settlement on the coastline, and you have a 200-foot tsunami hitting, again, there's not going to be anything there. You're not going to find potsherds. You're not going to find anything, really.
Yeah.
And so this is the problem. The problem is that they don't understand how powerfully the planet was affected by these events. And when you have 100,000 years and there's the glaciers come and go 4 times, think about this, a half mile to mile and a half thick glacier grinding over the landscape, covered more than half of North America, for example. Okay, now that glacier rapidly melts, How are you going to know what was there in that land before the glaciers came? Whatever the glaciers don't destroy, whatever the ice doesn't destroy, the meltwater, the huge volumes of meltwater and the ensuing floods is going to destroy the rest. And given it, if we look at the rise of modern civilization, Cliff, we see the two preferred places where we first see settlements turning into villages, villages turning into cities, is on coastlines and in river valleys, right? Think about the Sumerian civilization, Tigris-Euphrates River. Think about the Harappan civilization along the Indus River. Think about Graham's South American civilization along the Amazon. Think about civilization, the scale of the things we see along the Mississippi and Ohio rivers in North America. The list goes on. Egypt, of course, the Nile River, right? Now, if you have an event like the Younger Dryas, and the scale of flooding that we're talking about here, every one of those rivers is going to be overwhelmed. It's going to make, like what happened in Texas on the Guadalupe River, like nothing, like a trickle.
So the river gets huge, but do tsunamis come through a river? No.
No. Tsunamis come from the ocean.
That's what I thought.
Yeah. Like although, look, if you've got a river coming down to the coastline, that tsunami wave, the force of that can backwash up a river valley, and they will do that, right?
Are these single-term events? Like, let's give an example. Like, if we look at Cairo, where there's a tremendous amount of buildings, if the Nile River rises dramatically over, say, a day, does it stay that way? Does it devastate like a huge volume of water and then recede, or does it keep coming?
Yeah. Well, now, of course, it's controlled. They built the Aswan Dam, and it controls the flow. But before that, you would have every summer around late July, you would have the floods coming from the Ethiopian highlands in the headwaters of the Nile, the Blue Nile and the White Nile. Okay. That water would flow north towards the Mediterranean, and basically they had a whole ritual that they would do. The priests would get out and they would observe what's called the heliacal rising of Sirius. The dog star would rise after being invisible from the latitude of Egypt or from the latitude of Cairo. It was invisible for about 70 days. And then because of the Earth's movement around the sun, late July, you would see Sirius rise in the east just moments before the sun, right? And then the next day, the sun would have moved a little farther away, and the next day a little farther away. So each day you would see Sirius rising a little bit earlier, right? But there was that first day, and the symbolism of the dog is likely because they thought of dogs as giving forewarning. Dogs bark and they warn you of something, right?
Right.
The dog star, for whatever coincidence, and I don't think anybody claims it's other than a coincidence, but I don't know. I'm not convinced. Right after that rising, called the heliacal rising of Sirius, the dog star, heliacal because it's rising with the sun, the Nile River floods would come from the headwaters, right? They would sweep north to the Mediterranean, and when those waters drained off, they would leave a fresh layer of alluvium, that is the stuff that's being deposited, and so it builds up, and basically when the warning came that the floods were impending, which was associated with the rising of Sirius, they would vacate the valley, and the river would flood, deposit the alluvium, and they would go back and plant their crops. So that's kind of how it worked.
Yeah, I mean, the rumors are that the desert area of Egypt were much greener than they are now.
Oh yeah, I mean that's well established. I mean it's well established. In fact, the sand that covers the Sahara is relatively thin veneer, and if you remove that sand, what's underneath it is a water scoured bedrock landscape with channels and river valleys, the remains of huge lakes that were covered North Africa during several episodes. It looks like there was much more rainfall during the late Ice Age. Then there was also a period after the Younger Dryas, where there was more rainfall, down to between 6 and 7,000 years ago. And then the monsoon apparently shifted and those rains ceased, and then it became a desert. But yeah, there was a whole culture of people that lived in the lush Sahara 8,000, 9,000 years ago. And who they are or where they came from is not known, although a paper I recently read was speculating that they came from the west, migrated across, and ultimately maybe came from the area of the Atlas Mountains in Morocco, which
that's interesting.
Yeah, that is interesting, because what does that kind of suggests a connection, doesn't it?
I've had a couple of guys on the show, Randall, that have speculated that the northern part of on the Pacific side of Africa was where the land of Atlantis was, because they found some geological formations that were circular in format. I think we've talked about this before.
Yeah.
And I don't know if it was big enough to support a culture. The bigger problem for me is that they've had guys go out there. There's no evidence of foundations. There's no evidence of bricks, no evidence of any civilization there.
Right.
And even if it's a geological event that's a terminating event, you're going to see something,
Right.
it shows us formations of civilization. You know what I mean? Bricks,
Yeah.
walls, floors.
I don't, I have studied pretty deeply into the whole Atlantis question, mostly through reading Plato's two dialogues in multiple translations, including even slogging through the original Greek a number of years ago.
Wow.
One thing is very, very crystal clear. In his dialogues, Plato is Atlantis is described as being an island.
Yeah.
When you're talking about the Richat structure, Richat structure, I think it's a soft C.
Yeah, that's it. That
Richat.
formation, geological formation in Africa.
It's just, to me, it doesn't fit the bill. First of all, it's an island. It's not an island. It's like 1,500 feet above sea level. And Plato's pretty explicit that it was an island. And we could do a share screen right now if you wanted, and I could show you some things. Let's do it. Okay, so you see this red line? There's the Richat structure there.
Oh, there it is. Yeah.
Yeah, right down here. And then there's two confirmed impact craters, and they form a perfectly straight line. And I just pointing that out because it's kind of a coincidence, I think, unless it's part of the same, because the early first discoveries of Richat structure was that it was an impact crater. Now I think the consensus is that it's a volcanic event. If I go backwards here, let's see. Yeah, this is a cross section now, and it looks like it's this dome-shaped structure here that's down faulted. Like you can see, this is a fault line here, and this is a fault line here, and you got like this down here below. It says like rhyolitic magmas. Magmas like lava, right? Hydrothermal breccia is these up in here. What that is, breccia means broken rock, and this was stuff that was broken rock. The hydrothermal means that it was like hot water, right? And then you've got these different layers here. You've got, like it says, quartzitic sandstone in this upper layer here. Anyways, this is actually showing that there is a subterranean structure to this thing.
I'm sorry, you said that you're thinking, or their thinking is that it was a volcano at one time?
Well, it could have been, it was probably a magma plume that pressured upwards and created a dome. And here you can see in this, you see this is called a box
photograph. Yeah.
Yeah, this is, so you see it's actually part of this. There's a huge magma chamber below it. So if that magma is pressuring upwards, it can cause a bulge. Now, think of this. If you've got a layered bulge, Cliff, and then let's say you got a flat and it's multiple layers, and then it bulges up. You still got the layers, but they curve up. Now imagine you slice the top of it off. Well, what you're going to now see is a ringed structure, if that makes sense.
It looks artificial, and that's why I can see why a lot of people might have thought it was man-made.
Well,
very strange looking.
When you let's see here. This is all the scientific work on the Richat structure, which is also called the Eye of Africa. And
Wow, they've been looking at it for a while.
yeah, this goes back to what was the year here. This goes back, well, that's 2014, but this is
2008, right there.
2008. Yeah. It was discovered by shuttle flights.
Yeah.
And it was thought to be probably impact related, but now they're referring to hydrothermalism played an important role in the evolution of the Richat complex. It is responsible notably for the karst collapse central megabreccia formation. Karst is where you have limestone solution and it's almost like a vertical cave, right? Because, caves form in limestone where water flows through limestone. It erodes it out and it creates caves. But if it's like a vertical shaft, it's like a karst. A sinkhole would be like what a karst is. See,
Okay.
We don't need to get into. I've covered all of the hard
I
geology.
think the point I'm trying to make is you are somewhat in agreement with me and some others that the place that Plato called Atlantis was impacted by this event. We don't really have a mythology of the impact. We only have flood myths, right? Do we have Firestone, fire and brimstone mythology?
Absolutely, we do. Now here's a satellite view of the Richat structure.
Okay. Yeah.
And
wow.
What I'm going to do is a lot of times they're saying, well, it's a multi-ring structure, and Plato describes a multi-ring structure in Critias. Well, he's very explicit and precise about the dimensions he gives. So I've created a whole 3D model of the ringed structure of Atlantis, right? The ringed city.
Oh.
And that blue circle that you see right here, that's it to the same scale as the Richat structure.
Oh my God, it's tiny.
It's huge when you're standing there looking at it, but compared to the Richat structure, which is like 25 miles wide, it's much smaller.
So you're taking the Plato's or whatever information that we have on the Atlantis seaport, which was rings area, and you reproduce. Oh, is it?
Let's see here. So this is what this is as I enlarged. This is the scale, actually, what Plato describes here relative to the Richat structure. Then just for fun, I enlarged the circular city to roughly the scale of the Richat structure and superimposed it.
Oh, there you go.
You see, and it's not really the same when you look at it. But the main thing is that this is the true scale right here. This is based directly on Plato's description.
Mm-hmm.
Right? Numbers represent the distance in stades, and one Greek stade was 608 feet. That's well known. So the outer ring was 3 stades. So then the measure of that would be 608 times 3, or 924 feet. And then you had this ring of land, and this is all taken directly from Plato's description of the circular city. Then, so now you would have 924 feet here, 924 feet here. So times 2, you're now up to 1,848 feet, going from outer water ring, outer land ring. Then you get to the next water ring, which is 2 stades. And then the next land ring, which is 2 stades. Then you get to a water ring, which is 1. And you get to this, which was 5 stades in width. So you can just add them up, right? If you add all of these up, which is what I did, let's see here. We can see that it would be, let's go 3 plus 3 plus 2 plus 2 plus 5 plus 1 plus 1 plus, I'll just go 4 plus 6. We've got 27 stades. And that would be times 608 feet. So you're looking at 16,000 feet. So you're looking about 3 miles.
3 mile width.
3 mile width, yes.
Okay.
Roughly.
It seems very military to me. You think that was purposely done
maybe.
It doesn't seem functional, but maybe it was.
Well, Plato said then that there was this 300-foot wide canal
Hmm.
that connected to the ocean so that ships could come in. And
Right.
here's sort of a 3D oblique view. So this is let's say it's, of course, oversimplified. Let's say this is the ocean. You
Right.
got the canal coming in, and then there was a bridge that linked all of the rings, but there was enough room. It was elevated enough that ships could sail under the bridge, and you
Uh,
could have foot traffic or you know people walking or carts or whatever on the bridge, but underneath the bridge, uh, the ships could sail into the different rings. And here's more or less you can kind of get the picture. So
mm,
you see, there's an opening under the bridge, so a ship could come in the outer ring of water, sail through the canal, come to the inner ring,
okay.
sail through another canal, and ultimately get up here to which was the Temple of Poseidon.
Hmm.
So there you can
Nice.
kind of get the picture of it. That's oversimplified, but
Yeah.
it's all to the exact accurate scale that Plato describes. And
And where is this sitting off of? Close to the Azores or where?
well, I mean, nobody knows. This is a description. Whether it really
Yeah.
existed or not is one question. I don't
Yeah.
know the answer.
That's the problem. We really don't know where it's what.
However, there's two things, two parts to the Atlantis story. There's the geology describing the island complex and all of its attributes, which actually, in my opinion, fits the Azores better than any other place. Then there's the second part, which involves the description of this city, and which is phenomenal on its scale, right? Well, we could take the city completely out of the story, and we would still have a potential Atlantis in the region of the Azores that could have been a seafaring culture, but without all this infrastructure. See, there's two parts. Is this scale of this infrastructure plausible? I don't know. It would be an enormous undertaking to
Yeah.
actually have built this thing, right? But on the other hand, the geological description that Plato gives is pretty much right on for describing the Azores. And what the science now tells us is Azores is a part of a microcontinent. The Azores Islands are the peaks of mountains, and those
Right.
mountains are in the Azores microcontinent, and it's sunken. We could go through a lot of it, but so then here's Plato's description taken directly from his account. The inner island, 5 stades in diameter, 5 stades at 608 feet equals 3,040. And so I've gone through, worked all the numbers. And now this is interesting because 3,040 is a half a nautical mile,
Hmm.
which is, what basically sailors use. And a nautical mile is 6,080 feet. So interestingly, Plato's numbers line right up with our traditional methods of measuring distance, how sailors measured the distance. And then we have this magic number of 43,200. And that basically, if we take the basic unit that Plato gives us here, which is 3,040 feet, times this, it gives us the circumference of the Earth.
Okay.
And then if we divide that by pi, it gives us the diameter of the Earth.
Yeah, we don't know what, I mean, if you listen to Edgar Casey and the impact period that was destructive to Atlantis, was it when Atlantis was more of an island than a continent?
Right.
So we don't really know what it was. But if you were to choose another pre-Diluvian culture that was impacted by this Younger Dryas impact, what would you choose, Randall?
Well, here's the difficulty is, I mean, we could look at like the Solutrean culture in Europe, um, the origins of some of these, like the Berber culture in Morocco, the Basque culture there along the
Asks. Yeah.
border lines of where did these people come from? And I Well, let's see. I got another one here I could probably show you that would give you the idea. Uh, let's look at this. Yeah, it's beautiful. Well, Plato describes Atlantis as being outside to the west of the Pillars of Hercules, which is right here, the Straits of Gibraltar. And he says that when you sail west, and I have these quotes all in here, you come to a group of islands, and you've got Madeira, you've got the Canaries all in here. And then beyond that was the island civilization of Atlantis. And it turns out that right in the middle of the Atlantic, along the mid Atlantic ridge, there is the Azores called microcontinent. And it's this thing right here, right? And then Plato says if you keep going from there, you get to the true continent that's on the other side of the ocean, which very suggestive because supposedly the Greeks did not know about North America. Yet he describes North America. Now, the Richat structure is down here, right?
Right.
To me, the geography is wrong. The geology is wrong. The scale of the thing is wrong. There's no evidence that there was, like you said, there is evidence of probably hunter-gatherers.
But there's no artifacts of a civilization, really.
Correct. And here's kind of a oblique view. And I would argue that this area here is the best candidate there is for Atlantis. If Atlantis was real, this is the best candidate for it right here. And it fits his description as to the geography and the location. A lot of the geology matches what he describes. And it's also evident that it has undergone subsidence since the end of the last ice age, which is critically important for making sense of the Atlantean story.
Yeah, I mean that's a great map. But the other thing is there's a lot of evidence for very early Maya settlements in the Yucatan of Mexico, and it's my feeling that the Maya are a derivative of Atlantean people, but not just them. It was a multicultural race. We see it in the evidence of their sculptures and their reliefs. There's Caucasian, African-centric, Asian-centric, European-centric people that lived in Mexico. So
yeah. All right. So I'm going to do another share screen here. Let's go do this.
what is the color screen, Randall? Is that some kind of a geological scan that you just, this one? What is that?
Well, the colors are based on elevation above and below sea level.
Oh, it's a geological map. Okay.
Yes. Well, yeah, it's a kind of a topographic map.
Okay.
So the light green is higher. The darker the blue, the deeper it is, for example, in the ocean. And like up here in Scandinavia, that kind of beige, that means it's a higher elevation. And you can kind of see it. Let's see. Same colors here. See, the deeper blues are the deep ocean basin. And this would be the continental landmass here. This would be Europe. This would be North America. And this is it's basically a sunken microcontinent. And I'm going to show you, here we go. Let's see. I got to speed through here. Excuse me while I speed through. I'm going to get down to show you. As you can see, I got a lot of stuff here on Atlantis.
You got a lot. Yeah.
Yeah. Probably have to go through this as well. Let's see. There we go. Okay. So, okay, wait a minute. Here we go. So that's where I would put Atlantis. And that's pretty much the outlines of the Azores microcontinent. And the mountainous area here, the 9 islands of the Azores are the peaks of those mountains that are on this plateau. And there's evidence that it sank at the end of the last ice age. And I go into some pretty detailed explanation of how that describing that whole process. So here's the Azores microcontinent right here. You can see it. And you can see how it's west of the Pillars of Hercules. There are, as he describes, there are islands on the way to Atlantis. Then you get to Atlantis, and then if you keep sailing beyond Atlantis, you get to what he says the opposite continent that's part of the true ocean, which would be the Atlantic, as compared to the Mediterranean.
Does Plato actually use the word continent in his writing?
Well, he uses a Greek term that is translated as continent,
Because I
but he
didn't know that he was
more
describing.
so
Yeah.
more so he uses the term nasos, which is island.
Hmm.
And this would not be a true continent here. This is a feature now that's called a microcontinent.
Hmm.
And so let me show you here.
Wow.
This is what I would consider now the dispersal paths. There you got one path going to Morocco and the Atlas Mountains. There you got one going to the Canaries. There you've got one going to the Basque region. There you've got one going up to southern England. There you've got one going into the Mediterranean all the way to Egypt. There you've got one going down to Cuba, which would have been an outlier for Atlantis. Here you've got one going to the Yucatan Peninsula and the Mayan. So this fits exactly what you just said. And then I think we also got a migration to the southeastern United States.
So, I mean, I've always thought that there were satellites of Atlantis. These
Well,
are these are dispersal points for.
Certainly, obviously, when this thing sank, it was completely abandoned, right?
Right.
But there's those are completely compatible ideas and Plato describes that Atlantis was a far-flung empire and traded with all kinds of other cultures around the world.
Right.
So it's likely that these would have been outposts of Atlanta, and that would have been the natural places to go to seek refuge.
Yeah.
If the homeland was about to be destroyed, these places where Atlanteans had already set up shop would be the obvious places to go.
Now, do you have a sense of them being cosmologically sophisticated enough to get the hell out of there before?
Oh, yeah. Well, see, here's the thing. Sea levels started rising around 15,000 years ago. Plato describes the final destruction of Atlantis at 11,600, which is interestingly, the upper Younger Dryas boundary. Well, once the glaciers over North America and Europe started melting, sea levels started coming up. So if you have an island community, an island civilization, I mean, think about all the concerns now about, sea level might rise 2 feet in the next 50 years. And, we got to be all in panic mode because of how it's going to affect our culture and our cities and communities that are along the coastlines. Well, think about what a 400-foot rise sea level would do, right? Well, so if you've got sea levels coming up relatively fast, well, what's happening? Yeah, I mean, you can see it. You can see it from year to year. You're going to see those sea levels rising. And as they're rising, they're encroaching laterally and swallowing up land.
But my point, though, Randall, is we can see a comet's tail. We can see the impending, I would think, hit of an asteroid. Were they sophisticated at that time to be able to track it before an impact, other than the rising of the ocean, obviously? But my thinking is that they did have enough sophistication to tell through telescopes or through whatever else that something was going to impact.
Well, a close encounter of a comet is going to be a spectacular thing to see just with the naked eye.
But I mean, can they see it months ahead of time or years ahead of time?
Here's what you got to remember. Let me stop share here. Here's what you need to remember is that let's say this is the sun and this is Jupiter
Comet
out here.
Oh.
This is Jupiter. This is the sun. So now you've got a comet that's in an orbit that takes it out to Jupiter and then it comes back into the sun. Now, as that comet's making that orbit, it could possibly be crossing Earth's orbit, right? Mm-hmm. Every time that comet is coming in towards the sun, anybody on Earth, if it's coming close to the Earth, you're going to see it in the sky.
Okay.
It's going to be, and the closer it is, the more spectacular it's going to be, right? Yeah. So think about, do you remember Shoemaker Levy 9 in 1994 when 21 pieces hit Jupiter? Do you remember that?
Vaguely, I do remember it hitting when you said hitting Jupiter, that's when it caught to me. Yeah.
Yeah, there was a comet. Okay, so now here's what's happening.
Yeah.
As this comet's going around, let me do it this way. As this comet's going around, let's say here's Jupiter and it's coming around Jupiter and then it's coming around the sun. Well, under certain conditions, each passage of that comet will draw the heavy gravity field of Jupiter will draw it in closer. And that's what happened with Shoemaker Levy 9. It had undoubtedly been orbiting between Jupiter and the sun for millennia. But each time it made a passage, Jupiter's like sucking it in closer and closer. Then in March of 1993, it was discovered using telescopes. And Gene Shoemaker, Carolyn Shoemaker, and David Levy were co-discoverers, and they began to study it. And comet orbits are elliptical, right? And they have a certain geometry. So if you can recreate the orbital geometry, the shape and size of that ellipse, the orbital ellipse, and you can get the timing of it along enough of a section of that ellipse, you can now predict where it's going to be in the future. It took 3 months of observations, and they were able to predict that in the next go-around, it was going to pass the sun and head back out to Jupiter, and it was going to cross Jupiter's orbital path. But at the point where it's going to cross that orbital path, it just so happened that Jupiter was going to be right there at that moment, at that week. They were able to predict that this comet, which had been a single object, as it passed through Jupiter's hyper powerful gravity field, the gravity field ripped it apart into 21 pieces.
Wow.
Those 21 pieces spread out and came back in the second week of July 1994, just as predicted. Boom, boom, boom. One after another, 21 pieces slams into Jupiter. If any one of those pieces had hit Earth, would have pulled the plug on human civilization.
Really?
And if all 21 of them had hit the Earth, that would have been mass extinction. 80-90% of all species, humans, we would have been gone, right? This happened, and we witnessed it in 1994.
Yeah.
Right? So now here's the thing I'm trying to get at. If you've got an object that's circling the sun and even going out to Jupiter, and it ultimately is an impactor on Earth. There's two types of impactors we can think of. One, it comes out of the blue and we don't know it, no way to predict it because it comes on its own path. It strikes the Earth or it misses the Earth and goes back out into space, never to return. If that's a long period comet. A short period comet is orbiting pretty much in the Earth's orbital plane, the plane of the ecliptic. And if we know that things hit the Earth, well, before they hit the Earth, they're making this passage, this loop, and each loop, they're being drawn in closer and closer to that moment of impact, right? If you're a culture, you might witness a comet coming back like Comet Encke, which is part of the Taurid meteor stream, has a 3.3-year return. It comes back to the sun every 3.3 years. Well, let's say that's a big comet nucleus, because Encke probably was a small piece of a much bigger comet. So if you're watching that, and it's part of the Taurid, by the way, part of the Taurid stream, you're seeing that every 3.3 years, you're seeing this comet coming through the sky. First time you see it, it's pretty far out there. It's just a nice little sight. It looks more like a bright star with a tail. Now, 3.3 years later, you see it again, but now it's bigger and brighter. 3.3 years later, it's back again, and now it's even bigger and brighter, right?
Yeah.
You get what I'm saying? So just somebody witnessing this from the surface of the Earth might get pretty alarmed, say, hey, that thing is getting closer and closer.
So you're saying that the Atlantinians probably got the hell off the island fairly consistently because they're not guessing that the impact's going to come, and they knew it was going to be coming soon.
Yeah, and I think that there were whole, astronomical priesthoods whose job it was, we know this, to watch the heavens.
Yeah.
And in order to identify, let's say, precessional motion, you have to be obsessive sky watchers. And when we look at the tales of old, what we find over and over again is things like serpents, cosmic serpents, and dragons in heaven.
Yeah.
All of that. Well, that was the metaphor that was used for these celestial visitations of shooting stars, meteors, comets, asteroids, and all of that.
Yeah. What are we doing today, though, to cover our ass for?
Not much. We're not doing enough.
I'll tell you. What's going to happen if we see somebody coming close, a solid body? We don't have anything to do to deflect it, do we?
Well, we did. The DART mission was the first test to see if it was realistic to nudge an object that was on a impact trajectory with the Earth, to nudge it enough so it would miss the Earth. We have the potential. I mean, we could. I'm a huge advocate of the creation of a planetary defense system because I've been tracking this obsessively from the 1980s, and I know how frequently cosmic debris flies by the Earth that could have devastating consequences if it was just a little bit closer, right? It's an overlooked hazard because the old obsolete models are putting major impacts at tens to hundreds of thousands of years apart. The new data suggests that there's been a whole lot more impacts, more closely clustered than we had imagined 25 years ago. And I don't think we've adjusted to that because part of the problem is that there are vested interests, for example, that don't want humans to be thinking about cosmic impacts because that might detract from the manufactured narrative of a carbon dioxide driven climate change or global warming, which in my opinion is pretty much manufactured on flimsy evidence. And that's something we could certainly talk about in another episode. But every time now that there is what happened in North Carolina with the flooding, what just happened, and I knew instantly when this was going on that they would be trotting out the global warming scenario to explain it. But then that ignores the fact that there have been at least like 4 other equivalent scale flood events in that watershed in the last 100 years. So there's this whole agenda right now that is using the climate crisis, as they're calling it now, to control energy production, distribution, and consumption. And that's that is the final result of the implementation of net zero policies. Net zero is going to require total control of energy, all energy use, right? And then you've got, it gets complicated, and certainly it's something I feel is important to talk about. But the point is that things happen naturally, and humans could abandon the planet. We could all shut down our SUVs and our cars and quit using air conditioning and live in tents, right? But that's not going to stop catastrophic events, weather events from happening.
Yeah. I guess my point is that I haven't heard from NASA or any special space agency talk about repelling an asteroid or a meteor that could be a terminating.
Well, look up the DART mission, D-A-R-T. DART mission. Right. You'll find some stuff there. But the point I was trying to make, Cliff, is that there are factions, agenda-driven factions, that only want people to focus on carbon dioxide and what that's going to do. And that's important, of course. Right. But if to me, the possibility and potential of a cosmic impact is orders of magnitude more important than what carbon dioxide is doing, because carbon dioxide has a limited ability to capture thermal energy, and 400 parts per million is already past that limitation now. So most of the heat that is being captured by carbon dioxide in the atmosphere takes place in the first 50 to 100 parts per million. Okay. And then it declines rapidly from there, like what would be called an inverse logarithmic scale, so that each increment of additional carbon dioxide is only going to capture 1/10 as much heat as an equivalent previous increment of carbon dioxide. So the more you add up to a point, the more you add, the less heat's going to be captured. And we're past that. At 400 plus parts per million, we're past that. So it's not really an issue. Is the average temperature appear to be getting warmer? Yes, for two reasons. One, because our baseline was the end of the Little Ice Age, the coldest millennia of the last 10,000 years. So if you use that as a baseline, that would be like saying, oh, well, we're going to take early March as our baseline, and then in July we're going to argue that the planet is, planet is in a warming phase.
Yeah.
It's unprecedentedly warm. Well, yeah, it will be if your baseline is early March, and now you're talking about July. Well, the Little Ice Age was the coldest millennia of the last 10 or 12,000 years. So that's our baseline. The second thing is that a lot of the warming has to do with the growth of urban complexes. And most of our weather data comes from weather monitoring stations that were installed at airports. Well, if you look at an airport 50 years ago, and then you look at it now, what you're going to see is that it's, it may have been a rural airport 50 years ago, and now it's surrounded by concrete and asphalt and buildings, air conditioning, condensing units, all of these things like that are absorbing heat. And there's the cities now, some of the major cities are implementing mitigation efforts to lessen the impact of that urban heat island effect. Well, what you're not being told is when you're getting, here is the unprecedented warmest temperature ever. Here's records are being broken. What you're not being told is that those records mostly are coming from urban areas that anywhere from 3 to 10 degrees warmer than the surrounding rural countryside. That's called the urban heat island effect. So there's a lot of manipulation going on that people who have not looked into this don't understand. And so they're easily manipulated. They're easily indoctrinated into believing this is a crisis. Yet there are things you watch within the next month or two, we'll probably see a major flyby. They're coming by every few months now.
Flyby, and what do you mean by flyby?
A flyby, like an asteroid type object. Oh,
okay.
Flying by the Earth. Yeah.
Wow. Amazing.
But yeah, if you want to know about asteroid mitigation efforts, look up the DART, D-A-R-T, DART mission.
Okay.
And that'll tell you. So that's like our first inroads into this effort to look at how we might implement a planetary defense system. I now know a few people that are working in the Space Force. And at one point, Matt Lohmeyer, I don't know if you know who Matt Lohmeyer is.
Doesn't sound familiar.
He wrote this book right here, Irresistible Revolution, Matt Lohmeyer. This is him here. Lieutenant Colonel Matt Lohmeyer. He was set up as one of the second in command of Space Force when it was perfect. He's highly trained. He's like the Top Gun Tom Cruise movie guy. He's like that guy, right?
Yeah.
Anyways, he was in line to become head of Space Force, but he wrote this book right there about the wokeness that was infiltrating and infecting the military. And he didn't think this was a good thing. He wrote this book, and he went on a couple of interviews like we're doing right here, and he talked about why he thought it was going to harm the mission of the U.S. military. Mm-hmm. He got booted.
Wow.
During the Biden years. Yeah, he got the boot, which in effect proved what he was saying.
Yeah.
Here's this and millions of dollars invested in him to train him to become one of the top, and and I mean his resume is extraordinary. But so yeah, he got the boot for speaking his mind about this, and which proved his point right there. So anyways, what I'm getting at is before he got the boot, he was organizing a conference where he was going to have like 40 or 50 of the base commanders of Space Force, and I was going to go and I was going to present give a presentation on the importance of planetary defense and why I thought that should become a major part of the mission of Space Force. Well, then COVID came along and it didn't happen.
Wiped everything out. Yeah.
Wiped everything out. So then once they started opening up again and said you can start gathering, he started reorganizing to do the same conference. Well, Then his book came out and he got booted. And so it never happened. But I've since then, I've met a couple of people now who are in Space Force, smart young men that have gone into Space Force, and hopefully it'll come back around again. And if I get the invite or get the opportunity, I will most definitely go in and give my presentation on.
Yeah, I mean, you would think it would be more outwardly presented to the public rather than a black box or a black ops kind of a project for the military, because you got to tell people what the potential is. If there's an asteroid that's coming close to us that could affect not only our weather, but actually have an impact, that's pretty serious.
Oh
So,
yeah, absolutely it is. And it's like I said, it's an overlooked issue, which is too bad.
yeah.
I would really like to see more attention given to that. And I'm gonna I think I've got something here handy. Let me see if it's handy, and I will
This
show
is going
it.
to be your final graphic, and then we got to let you go. I promised 90 minutes, and we're getting over the hour there.
Oh well, yeah, and like I've got a hard stop coming up in a
Yeah,
moment.
yeah, that's why I wanted to kind of conclude us here.
Okay, well let's leave it with this then. I'll show you what I got here. Well, very quickly, just to create impression.
That's pretty harrowing, my friend.
Well, see, this is what people don't know. And so I've gone through here. You can see I started in the late 80s monitoring every close encounter we had. And you can see here, if I just go through.
Wow, you actually had the actual dimensions of these.
Oh, yeah, yeah. I've done a whole study. Near miss asteroid revealed as two bodies. All eyes on near miss asteroid. It was a close call for planet Earth. This is
Wow.
great. Yeah, on at midnight Greenwich Mean Time on August 10th, 1998, asteroid ML14 crossed the orbit of the Earth at the exact point that the latter had occupied 18 hours earlier. Had ML14 reached that point at 6 a.m. the previous morning, an area the size of France would have been totally devastated by 6:05. Most of the world's vegetation would have been in flames by 8 o'clock, and 30 to 40% of the human race would have been dead or dying by late October. Now, this was a near miss, and this is happening frequently. So you can see asteroid estimates too low. Asteroid makes close approach. Scientists worry over asteroids. Huge asteroid, narrowly, and these are all separate events. See,
Wow.
huge, large asteroid passes close to Earth. Asteroid buzzes Earth. Too close for comfort. Asteroid passed within 75,000 miles of the Earth. This is almost like scraping the Earth. See, so we could go through this, and it goes on and on and on.
It's amazing that they're actually presenting it as newsworthy.
But it's out there, but it's getting lost in the noise is what's happening, because there's so much bullshit now, Cliff, that people aren't paying attention to the to me, one of the most important issues facing our civilization right now is what I'm showing you right here, because it goes on and on and on. And that's why I call this While Mankind Sleeps.
Oh.
Well, part of what I'm trying to do, Cliff, is wake mankind the hell up and realize our planet is part of a larger ecosystem, and we've got to start thinking big.
Wow.
And that's my message. So I'm going to go out of here, stop share.
Randall Carlson, always a pleasure to have you on the program, and very, very insightful data. Hey, give us your latest social media. I know you got a new website you're building, but give us your website and how people can reach out to you.
RandallCarlson.com.
Okay.
That's going to get you there. Also, howtube.com. I'm partners with them now.
Okay.
And they're hosting all my stuff. I'm also on Rumble, but RandallCarlson.com should get you to where you need.
We should mention that you're rebuilding your website. So is the new one going to be up by end of summer, or no?
Oh, yeah. Yeah. It should be up at the rate it's going. It could be in 2 weeks.
Amazing. And we should also mention that you're going to be all over the media here shortly. So you still have celebrity status.
Yeah, all night.
Hey man, great having you on the program. You're a blast. I really appreciate it. Thanks for
Oh,
joining me.
thanks, Cliff. I've always enjoyed getting together with you. One of these days, I hope we have never met in person.
We
Have we?
haven't, you know, and we were going to meet at Cosmic Summit. I'm hoping to go next year, but get my act together, uh, and I'll meet you in person. So pleasure, pleasure.
Yeah. Shake your hand and give you a bro hug. Go have dinner, whatever.
Yeah, have a local brew. I'm a microbrew guy. So
Okay. All right.
hey, thanks again, man.
You got it, my friend.